Hello my Lenians, this is Teacher Zane and today we are going to discuss the topic sets. This video tutorial is based on your learning activity sheets in Mathematics 7 Quarter 1 Week 1. So, bring out your learning activity sheets and turn your learner's module to pages 1 to 7. Our learning target for this session is to describe well-defined sets, subsets, and the null set, cardinality of sets, and the union and intersection of sets. Before the lesson, let's have some warm-up questions. I have here some questions for you to answer. Here is the first one. Look at the following pictures. What is the common characteristic of this? Timer starts now. What do you think is the answer? Excellent! Those are all fruits. Now, here is the next one. Are all these fruits delicious? Think about it. Timer starts now. What is your answer? Great! Actually, there is no definite answer on this particular question because it depends upon your preference. Some of you may have answered yes because for you, those fruits are delicious, while others may have answered no. In this lesson, we will talk about sets. Let us first define set. Set is a collection of objects, things, or symbols which are clearly defined. The groups are called sets for as long as the objects in the group share a common characteristic and are thus well defined. Take note of the words common characteristic and well defined. In the pictures presented in the warm-up questions, you said that those are all fruits. If we are going to show this to other people, will they also agree that these are all fruits? Yes, definitely. So therefore, if we will name this a set of fruits, it is a well-defined set because everybody will agree that these are all fruits. How about if we will name it a set of delicious fruits? Very good. It is not well-defined set because it depends upon the preference of the person. Some may say that these are all delicious, but others may not. Let us differentiate the two. Well-defined sets. The elements of this set could never change and there is no difficulty in identifying the elements of this set. Not well-defined sets. The elements of the set may change and we may be confused in telling if a specific object or element belongs to the set or not. For examples, let us identify if the given sets here are well-defined or not. First one is set of beautiful students. Is it well-defined or not well-defined? Great! Set of beautiful students is not well-defined because you may be confused in telling if your specific classmate is beautiful or not. Next, set of even numbers. Well-defined or not well-defined? Fantastic! Set of even numbers is well-defined set because you can easily say if a specific number is an even number or not. Next, set of all multiples of 4. Well-defined set or not well-defined set? Awesome! Set of all multiples of 4 is a well-defined set because you can easily say if a specific number is a multiple of 4 or not. The last one is set of large numbers, well-defined sets or not well-defined sets. Great! Set of large numbers is not well-defined sets because of the word large. So we may be confused what that large means, so therefore it is not well-defined set. In writing a set, we simply list each element or member separated by a comma and enclosed in curly brackets, or sometimes called set brackets or braces. Let's have an example. Let's write the set of all multiples of 3 between 1 to 20. To do this, the first thing that we are going to do is to list each element. What are the multiples of 3 between 1 to 20? We have 3, 6, 9, 12, 15, and 18. After listing all the elements, it should be separated by a comma and then enclosed in curly brackets. So therefore, we now have here the set of all multiples of 3 between 1 to 20. When talking about sets, it is fairly standard to use capital letters to represent the set and lowercase letters to represent an element in that set. For example, set of letters in the word math. So, let us name this set as set L for letters. So since L is the name of the set, we should use a capital letter. Next, let us list the elements of the set. So in this case, the elements are the letters in the word math. Take note that in writing the elements of the set, it should be in alphabetical order. So if the letters here are M, A, T, and H, you have to arrange it in alphabetical order. So the first element must be A, followed by H, M, and T. So that is how you are going to write the set of letters in the word math. The individual objects in a set are called the members or elements. This symbol is used to indicate that an object is an element of the set. The cardinality n of a set is the number of its elements. Example: R is a set of odd numbers between 10 and 20. Let us identify what are the elements of this set. The elements are 11, 13, 15, 17, and 19. So it means that 11 is an element of R. 13 is also an element of R. 15 is also an element of R. And same with 17 and 19. So that is how we are going to use the symbol for element. This given set can be written as R equals 11, 13, 15, 17, and 19. To identify the cardinality of this set, what you are going to do is just to simply count how many elements are there in this set. So we have 11, 13, 15, 17, and 19. So therefore, there are 5 elements. So the cardinality of this set is 5. When we define a set and take pieces of that set, we can form what is called subset. This is a symbol for subset. For example, let us list down all the subsets of set C whose elements are A, C, and T. Take note that in writing a subset, it is similar as writing a set. That should be enclosed with a set bracket or curly brackets, and each element must be separated by a comma. To start listing the subsets of this given set, let us first take one element at a time. So we have A, C, and T. So these are the first three subsets of set C. And now, let us take two elements at a time. We have AC, CT, and AT. So these are also subsets of set C. And finally, let us take three elements this time. So that is A, C, and T. We cannot take 4 elements anymore because there are only 3 elements in the given set. So these are the subsets of set C. In general, the number of subsets of a given set can be determined by using the formula 2 raised to n, where n is the number of the elements of the set. Let us apply this formula in this example. We have 2 raised to n equals 2 raised to 3 because there are 3 elements in the given set. So, evaluating 2 raised to 3, 2 times 2 times 2 is equal to 8. So, therefore, there should be 8 subsets. If we will count these subsets, we only have here 7. Where's the other one? We have what we called null set. Null set is an empty set, so it means that there is no element in a null set. So null set is also a subset of any set. These symbols are used to refer an empty set or null set. In our previous example, it means that the missing subset is the empty set. But take note that the set itself and the null set are not proper subsets. So in the previous examples, we only have 6 proper subsets. Now, let us proceed to union and intersection of sets. The union of two sets A and B is denoted by this symbol. We can define the union of a collection of sets as the set of all distinct elements that are in any of these sets. This is the set of all distinct elements that are in A or B. For example, if A is equal to 1, 3, 5, 7, and 9, and B is equal to 2, 3, 5, and 7, what is A union B? To find A union B, list down all elements that are either in A, in B, or in both of the two sets. So, A union B is equal to 1, 2, 3, 5, 7, and 9. So this is our A union B. Now, try this one. If C is equal to 6, 12, and 18, and D is equal to 1, 2, 3, 4, and 5, what is C union D? Excellent! C union D is equal to 1, 2, 3, 4, 5, 6, 12, and 18. How about this one? If E is the set of letters in the word corona, F is the set of letters in the word virus, what is E union F? This time, you have to list down first what are the elements of the two sets E and F. Remember that in writing the elements of the set, it should be written in alphabetical order. So therefore, our set E is equal to A, C, N, O, and R. And our set F is equal to I, R, S, U, and V. After listing down the elements, we can now easily identify what is E union F. So just identify what are the elements that are either in E or in F or in both of the two sets. So therefore, E union F is equal to A, C, I, N, O, R, S, U, V. Notice that in our final answer, the elements are also written in alphabetical order. This time, let us discuss the intersection of two sets. The intersection of two sets A and B is denoted by this symbol. We define the intersection of a collection of sets as the set of all distinct elements that are in all of these sets. This is the set of all distinct elements that are common in A and B. For example, if A is equal to 1, 3, 5, 7, and 9, and B is equal to 2, 3, 5, and 7, what is A intersection B? To determine A intersection B, we just have to list down the common elements in set A and set B. So therefore, A intersection B is equal to 3, 5, and 7. So that is how to determine the intersection of two sets. Okay, so now let us try another one. If C is equal to 6, 12, and 18, and D is equal to 1, 2, 3, 4, and 5, what is C intersection D? So again, to identify the intersection of these two sets, determine what are the common elements in set C and set D. Very good. In this case, there is no common element in the two sets. So therefore, C intersection D is a null set or an empty set. How about this one? If E is the set of letters in the word corona, F is the set of letters in the word virus, what is E intersection F? Just like what we did, in the union of sets, we have to list down first what are the elements of E and F. So again, E is equal to A, C, N, O, and R. And F is equal to I, R, S, U, and V. After listing down the elements, identify what is the or are the common element or elements in the two sets. Nice one. So E intersection F is equal to R. Now, look at your learning activity sheets. There are enrichment activities there for you to practice what you have learned in this lesson. Reminder, do not write anything on your activity sheet. Write your answer on a separate long band paper. For enrichment activity 1, determine if the given is well-defined, not well-defined, or null set. Write a check if it is well-defined, cross if not, and the symbol for empty set if it is a null set. For enrichment activity number 2, identify the elements and the cardinality of the given sets. Again, write your answer on a separate long band paper. And for enrichment activity number 3, list down all the subsets of the given sets. For enrichment activity number 4, refer to the given sets and then answer the succeeding questions. For the wrap-up activity, give 3 examples of well-defined sets in real-life situations and then write at least 5 elements of that set. I hope you learned something today. If you have questions or clarifications regarding the topic we discussed, feel free to contact your subject teacher through text, call, or post your questions in your official Facebook group. Thank you for watching. Don't forget to like and subscribe.